vertices, or your foci.
Yeah.
A lot of times the directions would say sketch it. This one didn't say to sketch it, but to answer a lot of the questions, you end up sketching a lot of it anyway, probably, don't you? I mean, you don't have to. If it doesn't say sketch it, you don't have to sketch it, but I think sketching it is helpful, just to get the points right and everything. Probably just want to be, if the directions say to sketch it, that just means you want to be careful. You don't draw a good sketch on a quiz. And be more careful with it. If you're just sketching it for your own help, then that's probably different. All right, so let's review hyperbola here just a little bit. So what's important about that? Once you get standard form, what's important about that equation? What are some of the important characteristics in that equation? The A is always the first number, so A is going to be 8. And what's important about A? It's how you find your vertices, right? That's true on an ellipse and a hyperbola, right? So A is important from that standpoint, okay? What else is important about A in this case? Or what comes first? The X, right? The X comes first, which means the 8 is going to be horizontal, right? You're going to go horizontally with the A, which means the hyperbolas are going to wrap around the X-axis, right? They're going to be open horizontally. And the foci are going to be what direction? Same, right? A and C always go together. Now, on one term I didn't use last Wednesday, or this Wednesday, I'm sorry, when we were doing hyperbolas was we talked about on an ellipse the major axis and the minor axis. On a hyperbola, and A is always on the major axis of an ellipse. Okay, A is on the major axis, and so is C. And then when it comes to hyperbola, A and C are always together, but they call it the transverse axis. Now, was that in any of your homework problems? Did it use that term? It may come up in some worksheets or something. It wasn't on the worksheet yesterday. You don't remember that? Okay. The transverse axis is what they call the axis where the A and the C are on a hyperbola. And that's just important. The reason they don't use major, because remember, A might be smaller than B when it's a hyperbola, right? So in an ellipse, A is always bigger, so major axis, minor axis. On a hyperbola, they call it the transverse axis. And then the other one, the one with the B, is the conjugate axis. Okay, those are the terms they use. So transverse axis, it has an A in it. So conjugate has an A in it too. Okay, so anyway, so that's a bad idea. Conjugate has a C, but that's not where the C is. Okay, so that's a bad idea. Okay, so anyway, the transverse axis is like the major axis. Okay, transverse is like the major axis where the A and the C are. Okay, all those things. All right, so those are all the different things you're looking for. So I think I did those. You agree with those numbers? And you should simplify this, but it's not huge. And if there's a radical in there, I don't care about that. But if it's 6/8, I mean, change it to 3/4, but probably not going to count off that. And then remember, when you write the equation of the asymptotes, it's always the y over here. We always want y equals when we write the equation line. Remember, all that is two line equations, one with a positive slope, one with a negative slope. So we always like those to have a y equals kind of look to them. But we go ahead, so you always want the y minus 3 over there, and then the x plus 2 over here. Okay, so just make sure you do that. And all that is, I mean, really all that is you don't, when you're in algebra class learning about lines and stuff, you don't really talk about shifting and moving. But now that we've talked about all of these, different functions and talked about moving and shifting them, really a line is just a function. So it makes sense that a line equation could be written this way, where we're just taking, your normal line, we talked about normal parabolas, or we talked about other functions, the normal sine curve, and then we talk about shifting it and stretching it, right? There's a normal line. It's y equals x. It goes through the origin, right? Well, these lines have been moved 2 to the left and 3 up. And so sure enough, here's your 2 to the left on the x, and here's your 3 up kind of thing. Now, to be honest, that's not really how we did sine, the 3 up, with plus 3 at the end. Well, if we would get a y by itself here, if we would add this 3 over at the end, that would be our 3 up, our shifted 3 up. But we just go ahead and write up y minus 3 here just to keep it consistent with what's here. But it wouldn't be wrong. Matter of fact, I probably would prefer it, but I thought this would just be easier for us to do for right now. But it wouldn't be wrong at all for us to just add this 3 over here and do it. I just think it's nice to write it this way because it matches with those. Okay, but just so you kind of can understand those connections, with different things we've done before. Okay, one more here, kind of the reverse deal. So here's a graph. Now you write the equation. Okay, so basically to get the equation, it's either the center, you need the A and the B, right? Now, this particular problem, I pretty much just gave those to you. So both of these were pretty basic problems. The first one, the first 4 scenarios there, we just had the equation. It was already in standard form. Everything was nice and neat. Numbers all came out nice, right? And you could find all those values. And here, again, pretty much gave you the A, gave you the B. What you had to remember is you had to have the Y first, right? Because the y, it's wrapping around the y. It's a vertical, if you will, hyperbola. Your center is at 5, 2, so 5 goes with the x, but y has to come first here, okay? Your a then, it'd be this number here, which is 2, so a squared is 4. Your b is this number, that'd be 1. Yes?
I guess I just have a question, like what does the box really mean?
Well, the box is there to get the asymptotes.
Oh.
Okay, so let's talk about that again. The box is there so then you can draw the diagonals of the box, which are the asymptotes. The asymptotes are what the hyperbola, so this is where we were talking on Wednesday, where a hyperbola is different than a parabola. A parabola is really more U-shaped, and it comes up and it goes up higher and higher and higher. A hyperbola actually comes out and approaches these asymptotes, and it gets closer and closer to them, and it becomes almost linear. the hyperbola becomes almost linear as it goes out. And so when you draw your hyperbolas, you kind of want to mimic that. You kind of want to have them go towards those. What you don't want to do, especially on a problem where you're supposed to graph one, and it's supposed to make it a decent looking graph, what you don't want to do is you've got your asymptote here, okay, and you don't want to have your hyperbola kind of come out and do this, like a parabola, where you have it going away from the asymptote, because that's not what it does, right? Now, that might be what a parabola would do. A parabola would kind of look more like this, but a hyperbola is going to come out, and it's going to get closer and closer and follow right along. So you almost want it to come out here and straight and get, closer and closer. Okay, so it's a subtle difference, but it is a little bit of a difference. Okay, all right. Any questions on that homework worksheet or the worksheet you were working on yesterday? This one here.
Number 6, I think on that side.
Number 6 on this side.
Yeah.
Okay. Okay, so one of the things we want to kind of work on the next couple days is just make sure we're good with the completing the square, getting into standard form. So that's a lot of what we'll have work time on, getting into standard form. Because what we've just shown up here for the hyperbola, and you did some work yesterday with the ellipses, is just, if it's in standard form, how do we draw it? What's the A and the B? If you got hyperbola in standard form, how do you write it? That kind of thing. But then getting into standard form. And then this kind of story problem kind of thing. So it says an architect's designing an elliptical pool for a home. Okay? The ratio, so it doesn't really matter what direction you go with it. Okay? The ratio between the lengths of the major and minor axis will be 3:2. Okay? If land available for the pool is 60 feet long and 30 feet wide, what are the maximum lengths for the axis? So if this is going to, so basically that's saying if that's going to be 60 the long way, okay, and you want the maximum length, so you want to use up the most amount. Okay, so what does that tell you your major axis has to be? 60, right? Then, and you have 30 feet in width. Well, if it's going to be in the ratio of 3:2, if this is 60, then what's this going to be? 40, right? 3:2. So ratio of 3:2. If you want the long side to be 60, then what's that going to be? So it would be 40. Well, what's that mean? Can't do it. Can't do it. So this can't be 60. So we're going to be more limited by the 30, right? So now let's talk about this. So if this is going to be 30, then that means if you're going to be in the ratio of 3:2, then how long does your long side need to be? 45, right? You'd have 90 divided by 2. So you're going to need this to be 45. So what we just figured out there is this is going to be 45. So what's that? What's A going to be? What would, and well, oh, is that all they wanted?
Yeah.
No, that's all they wanted. I thought we were going to write the equation and all that. I thought we were going to have to write the equation. But we're not, but we could. So remember, this A would be 22.5 then, and this would be 15, right? So the idea is the maximum is available. So if this was going to be 60 and it was going to be a 3:2 ratio, then that means that would have been 40, and that wasn't enough space. Okay, so that's it. So the major axis would be 45 feet, and then 30 feet for the minor. Okay? All right, what else?
On the ellipse side, on number 4, is the semi-major axis just another name for?
On this side? Yes.
Yeah. The
This-
semi-major just a different name
For
for
what?
the minor?
Number 4.
Yes, this one.
Yeah.
Is so the question is, so let's see, somebody pitch in here. The semi-major axis is another name for,
The radius.
well, okay, we haven't used the word radius, we kind of did. I mean, yeah, there's a longer radius and a shorter radius.
Yes.
Half of the major axis, that's what semi means. So half of the major axis is, what do we call that though? That's A. That's A. Okay, so that's good. That's a good question because, okay, so a lot of times you'll see they'll talk about major axis and they'll call it 2A, and the minor axis is 2B. All right, and same thing on a hyperbola. Transverse axis is another name for 2A because that's what we have. If this is our center, the long side is A. It's A both directions, so it's 2A. So the major axis is 2A. So the semi-major axis just means half of that. So it's another name for A, basically. Yeah. Yeah, there's a lot of, and again, that's part of what we're going to make sure what we're going to spend a lot of time working on is all. I think we're pretty good at understanding the basic stuff of AB, finding C, the eccentricity. We got the gold sheet, so we can always double check if we need it. When it's in that form, but it's just getting that information when it's given to us in maybe a non-traditional way. With words like semi-major or whatever. And so we can find that information when we need it. Okay? All right. What about 9 down here? What'd you get for number 9? Circle, right? Remember, and that sometimes can be confusing. Anytime you have an x squared, and these are your only choices, circle, parabola, or ellipse. Circle and ellipse are related, and I do want you, because I think it seems like somebody in the quiz or maybe it was on one of the worksheets or something, put circle/ellipse. Okay? I want you to give the most specific name you can. So it's kind of like square and rectangle, right? If you've got something square, and you're supposed to identify it, you call it a rectangle. Well, technically you're right, it is a rectangle, but the most specific name you can give it's a square. And that's the same thing we have here. So if you have a circle, technically you could call that an ellipse, right? A circle is kind of a special case of an ellipse, but the most specific name would be circle, right? And so whenever you have the coefficients on the x squared and the y squared the same, it's going to be a circle, okay? Because what will happen, even when you complete the square, right? Even when you complete the square, you're going to have a 4 on the x, you're going to have 4 with something squared, and you're going to have 4 with the y squared, and then you're going to have, stuff over here, and you're going to want to divide those over there. Now, so let's talk about this a little bit, the getting it into standard form. Okay, first of all, now I misspoke, but I didn't really misspeak, but I probably did tell a little story right there. I said whenever the coefficients of the x squared and the y squared are the same, it's going to be a circle. Providing what? Providing that they're both the same sign also. What if there was a minus sign right there between those 4? Now what do you got? Now you got a hyperbola. Now, but you might say, see, here's what you would never see on an ellipse. This is good stuff that is kind of maybe something you wouldn't always run into, but if you did, it would be confusing. Would you ever have an ellipse equation? Let me just do a. Would you have an ellipse equation like this? Well, if you thought you were doing an ellipse, and then of course you go, well, A is supposed to be the long side. Well, it isn't long. Well, you got the X, you go 3 and 3. On the Y, you go 3 and 3. What do you got? You got a circle. So what you'd want to do, you wouldn't want to write it like this. So if you're thinking to yourself it's an ellipse, of course you're thinking, hey, I got to get 1 on this side, right? And you do that, but then you look at, well, that's silly. I just multiply everything by 9, and then I get this, which is, our circle equation, radius 3. Now, what about if you had this? That is a hyperbola, though, isn't it? That is a hyperbola. You wouldn't want to multiply the 9 over here and have this with a minus sign in there. That's not good. That is not a circle. You don't want a minus sign here. You would not do that. You'd want to do this. Well, all that means is what? You'd go 3 and 3 this way on your X, 3 and 3 this way, and your box would be actually a square, all that means is your box would be a square. When you do your asymptotes, they would have a slope of 1. It'd be up 3/3. They would just have a slope of 1, and you would just still do your hyperbola. Now what would matter is which one comes first, right? Which one comes first on your x. So you could run into that. So just understand the minus sign overrides the fact that they're the same there. So if the x squared and y squared are both the same coefficient and the same sign, so therefore it's positive, if they're both negative, you divide a negative out of there, and then they both become positive, and you'd have an ellipse or a circle plus, okay? So, but if they're different signs, so one of the x squareds is positive, one's negative, that's when you know you have a hyperbola. But it's possible that your a and b are the same on a hyperbola. They wouldn't be on an ellipse because then it would be a circle. Okay? All right. So those are just some of those little things that I know we're going to be running into, which is why I don't want to just kind of rush the quiz and make sure we get a chance to look at some of that. Okay. Anything else? Okay. All right. So let's do this for a little while. We'll probably have more time for IXLs actually on Monday, but let's see how we do with this thing here. So each group, you get a partner, whatever, everybody needs like a set of light colors. They are kind of, if you're careful, they're kind of paper clipped together. Now what it is, it's a matching thing. So you'll have a sheet here. You'll have a sheet here that's got 8 ellipses on it. So each group will need like one piece of paper to write it out on. And then, so for each of the different equations, you'll match a focus and a vertex and or each of the different graphs, excuse me, you'll match a focus, a vertex, and so forth. Okay? All right. So, there you go. They're on Allie's desk. Thanks, bro.
Oh my God. It might be all right. No. Yo, I smell watermelon.
So actually, this, excuse me, this would be a good way to write it on your paper. This will make it easier for me to check. So if you would do your equations, if you pull out all the equations, they're listed 1 through 8. Okay, so if you would kind of do them in that, now I don't care what order you do them, but on your paper, if you would write it out like this, and get it on a blank piece of paper so you can hand it in, like not on the back of your notes or something, right? Get out a sheet of paper that you can hand in. And then let's do it in this order. Then let's match the center. So put the letter or the number of the center, not the actual coordinate, but what if it's, number 1 goes with B or whatever. Now there are a couple of them that are the same. Like there might be several that have the same center. Okay, so it doesn't matter. You can use, I think H, C, and F all have the same center. There's 3 of those that are the same. So which one you put it with doesn't matter. And then foci, vertices, and then the graph. Do it in that order. Just make sure your groups are no bigger than 4.
Yeah. that turn in. I'm almost out of my water. So that's
Write this down now.
Girl, let's put some miles on it. Anything you want, just to put a smile on it.